I have spent this week implementing buoyancy into my project. This was relatively simple, but some of the more subtle nuances of buoyant object behavior took some time to figure out. For example, the physics of how an object is pushed up by the water. In a true physics simulation, this would be done by using particle displacement and density calculations, but as these are difficult to achieve in real time, I instead opted for an inverted gravity approach. Let's run backwards through the code. As the object drops further below the water level, the more of a force opposing gravity is applied, pushing the object back up to the surface. A damping value is applied to stop the object from infinitely bobbing up and down, simulating the loss of kinetic energy. This gravity-opposing force is proportional to how deep the object is. This is further modified by a float depth value, which determines the density of the water. The action point here is the object's centre of buoyancy, which can be offset from the object's spatial centre. Lastly, these if statements update the working water level based on the nearest water surface. This is done by a simple vertical raycast. If no water is found, the water level is set to an arbitrarily large negative value, so the object drops normally with gravity. For next week, I will look towards more complex, less uniform wave calculations.